We are looking at a fundamental shift in one of humanity's oldest endeavors today. I mean, think about the massive global challenge we're facing right now. We have to produce enough food for a rapidly growing population, but we also have to actively protect our planet's limited resources at the exact same time. So to solve this, agriculture isn't just scaling up, it's getting significantly smarter. We are unpacking the incredibly complex, yet totally fascinating world of UAV-assisted edge computing for smart agriculture. Okay, let's dive into this, because this is where the story gets really fascinating. What actually happens when you inject a millennia-old practice with localized artificial intelligence and autonomous drone swarms? Look, we aren't just talking about strapping a GPS to a tractor anymore. No, this is a complete evolutionary leap. We're moving from basic human intuition to hyper-intelligent predictive data networks that are literally working in real time. So just to establish our baseline here, let's define smart agriculture. It utilizes a whole mix of tech: IoT, AI, edge computing, and UAVs, or drones. But focus on that final, absolutely crucial point: optimizing farm operations in real time while minimizing resource use. That is the core key here. The goal isn't just throwing flashy tech at a field to look modern, right? It's about achieving absolute hyper-efficiency. It's about knowing exactly what a single plant needs, right when it needs it, without wasting a single drop of water or an ounce of fertilizer. Farming has obviously gone through some pretty distinct eras. We've moved from the back-breaking manual labor of agriculture 1.0 through the combustion engine mechanization of 2.0, and then into the GPS-guided precision of 3.0. But we are accelerating way past those basics now. Today, we've arrived at agriculture 4.0. This is an era where the farm is a fully integrated, digitally connected ecosystem driven by AI, massive streams of big data, and edge computing. The journey from 1.0 to 4.0 brilliantly illustrates a stark contrast. On one end of history, you have a highly reactive, labor-intensive process, a farmer physically guiding an ox through the mud, basically just hoping for the best based on historical intuition. On the other end, a sleek, autonomous drone scanning and spraying crops from above. We've literally replaced the ox with a flying, data-gathering robot that communicates with thousands of ground sensors in real time, executing complex algorithms before the farmer even wakes up in the morning. To really put this into perspective, traditional farming relies heavily on uniform input application. Think about it. That means spraying an entire 100-acre field with expensive chemicals just in case a few patches have pests. It is, honestly, incredibly wasteful. Agriculture 4.0 flips this completely on its head. By using continuous, site-specific precision farming and AI predictions, a drone can identify a single diseased leaf on an apple tree and treat only that exact square meter. It drastically optimizes resources, protects the surrounding soil, and vastly improves the overall yield. Now, what's really interesting about this ecosystem is the sheer scope of the revolution. Agriculture 4.0 isn't just one isolated piece of technology. It's a highly complex, interconnected web. Notice how cloud computing blends seamlessly into robotics, which is directly interacting with IoT sensors and artificial intelligence. Each of these represents a massive technical domain on its own. But here, they seamlessly merge to create a living, breathing agricultural network that learns and adapts every single day. So how does this actually organize itself in practice? Well, the 7-layer architecture is a masterpiece of modern network engineering. Down at the foundation, layer 2, you have your physical assets out in the dirt. We're talking crops, tractors, and livestock. Then, as you move up, layer 3 collects the data. Layer 5 processes it locally at the edge for speed, going all the way up the stack to layer 7. And that final layer is the user dashboard. That's where the farmer actually sees all this intelligence, visually synthesized, and can take action. Let's demystify the perception layer for a second, because the tech happening right at the ground level is brilliant. It takes a few steps. Sensors digitize physical signals, they run write-write pre-processing, and then they execute what's called TinyML. Basically, this means running miniature machine learning models right on the device for millisecond-level decisions. If a smart sensor detects a sudden moisture drop in the soil, it doesn't wait to send a request to a server hundreds of miles away. It triggers local actuation, opening a water valve instantly. It's blazing fast, and it only sends quick summaries up to the cloud to save critical network bandwidth. Let's move up a bit and see how this builds. Sitting just above the ground level is the access, or fog layer, which acts as the crucial gateway between those local sensors and the wider internet. Its functions include protocol translation, edge filtering, and local policy enforcement. But think about that final function: store and forward session continuity. This is absolutely critical in the real world. If a rural farm's internet connection drops because of a bad storm, the highly automated system doesn't just shut down and let the crops die. This edge gateway stores the data locally to keep operations running securely and seamlessly, and then just syncs with the cloud once the connection is restored. So the crucial point is how all these invisible layers of computing translate into tangible physical action in the dirt. Imagine an agricultural drone actively orchestrating field operations. It collects data directly from IoT sensors on the ground and even commands smart tractors moving through the rows. Sitting right at the center of it all is the AI, making the UAVs the literal eyes and hands of the network, autonomously managing crop health from the sky with a precision no human could ever match. And really, why does this matter for the future of our planet? Well, by enabling multi-UAV collaboration and real-time crop monitoring, we achieve pinpoint precision for pesticide spraying and intelligent irrigation scheduling, all powered by this cloud edge integrated architecture. We aren't poisoning the surrounding environment with excess chemicals, and we certainly aren't draining local water tables dry. An advanced smart farm can generate over 500,000 data points a day. And that's not to overwhelm us, it's to allow this architecture to lay the foundation for a genuinely sustainable future. We are literally learning how to produce far more food with drastically less environmental impact. Which leaves us with a truly profound question to ponder. As our farms transform into these highly automated, intelligent networks, driven by artificial intelligence and edge computing, what exactly is the role of the modern farmer going to look like tomorrow? Are they going to be data scientists, drone pilots, ecosystem managers? Honestly, the human element of this technological revolution is just as fascinating as the tech itself. Thanks for exploring this explainer with me today, and keep asking those big questions.